Okay, grade 8, now we're doing translations. Now this is transformation geometry, so transformation is any kind of change. A translation, as you will find, is a simple change. Let's have a look at that example with the snail. So translation is simply moving a point. There's no rotation and there's no reflection. So we have our snail. We put our coordinate system on our snail. We put our axes, our x-axes, and we simply want to, or we make the x-axis bigger rather, we put our y-axes, and we simply want to translate the snail down. We just simply move him down. We copied him. What if we want to copy him across? We simply copy him across. We add our coordinate system there, we extend it. This is a very simple translation, right? So there's no rotation, there's no reflection. That's the exact same image 4 times. So here we could add our rectangle and we move it down, there it is. We move it across, there it is. We move it down, there it is. The exact same size, the exact same orientation, just in a different position. So let's look at translations. We move a point either up, down, left, or right, a specific amount of blocks. Right, so the snail, we moved it down, we moved it right, or we moved it down and right. Right? That's what I mean. So diagonally is simply a combination of up, down, and right. So if we went up 1, right 1, we've gone diagonally. So let's look at this point here. If I want to simply move this point across 4, I move it there. Right? So it's not a reflection. It could be the same, but we're just moving it across. I could move these 3 points as well. Right? So this is now, I move this point all 4 across. So we went 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. And that is simply a triangle that we've done, and we've moved that triangle across. It's exact same orientation, exact same everything. We could also move it diagonally, and we have our triangle there. But now remember, if I'm moving it diagonally, it's the same as moving it down and across. So here I move down 1, 2, 3, 4, and I move across 1, 2, 3, 4. So let's have a look at this example. I move down 1, 2, 3, 4, and I move across 1, 2. I move down 4 and across 2, and I move down 4 and across 2. And there's my triangle again. And that is a translation. Let's have a look at this example. What are the coordinates of A, B, and C? Okay, we just keep practicing coordinates. Point A, we have -1, -2x. We say x first, and then y is 1, 2, 3. So it is -2 and 3. B is -2 and 2. And C is -4 and 2. We draw a triangle there. Triangle is just an example of what we're using each time. So you are asked to translate the shape. X and y must go to x plus 6 and y plus 1. Right? So how are we going to do that? For every coordinate here, x must go plus 6 across and y must go plus 1. So we're going to call this A dashed. A dashed, x plus 6 minus 2 plus 6 is 4. 3 plus 1 is 4. So we're going to move that A to 4 and 4. That's 1, 2, 3, 4, and then 1, 2, 3, 4. That's going to be our A dashed. What about B dashed? -2 plus 6, that's going to be 4. 2 plus 1 is going to equal 3. So that is just below B dashed. And what about C? C dashed is going to equal -4 plus 6. -4 plus 6 is equal to 2. And then 2 plus 1 is equal to 3. So it's going to be 2 and 3. So 1, 2, 1, 2, 3. And that is our triangle. What if I asked you to translate it x plus 5, y minus 3? I'm going to call this A double dashed. So we're going to go x plus 5 minus 2 plus 5 is plus 3. 3 minus 3 is 0. So that's going to be 3 and 0. A is now 3. So this A double dashed is now 3. Oh, sorry, what am I doing? Let's remove that. A is 3, 1, 2, 3, and 0. Oh, 1, 2, 3, and 0. That's A double dash. Okay, where would B be? b double dashed is equal to -2 plus 5 is 3. 2 minus 3 is minus 1. So it's going to be 1, 2, 3x minus 1 is b double dashed. And lastly, c double dashed would be -4 plus 5 is positive 1. And then the last coordinates would be 2 minus 3 is -1. So that's going to go positive 1x minus 1y, and then we can draw our triangle. Okay, let's have a look at another one, where we said xy goes to x -1, y -5. What we can do now is we can just solve one equation. Let's call that, remember that was c double dashed. Let's now call this a, that we're trying to solve, a triple dash, right? So we're going to go x minus 1, x is -2, minus 1 is -3, y minus 5, 3 minus 5 is -2. So -3, so we have x is -3, 1, 2, 3, -2, 1, 2, and that's going to be a double dashed. And now we can simply draw the rest of the triangle in there. And I want to do one last one where we go xy goes to x and y. So here we're going to have a quadruple dashed, gets a bit outrageous, goes to x stays the same, is -2, and then y goes to 5. So we're going to have x is -2, 1, 2, and then y goes to 5, 1, 2, 3, 4, 5. And this is a quadruple dash, and that's going to stay here. We have the following translations, right? What are the coordinates of a, b, and c, or a dashed, b dashed, and c dashed? You see here I've put a dashed, b dashed, and c dashed. So we know that a, I'm going to give you those. A is -2 and 3. What is a dashed? Okay, a dashed is easy. We're going to have to put that here. So x is 0, and y is -2, so it's 0 and -2. Right? Let's complete the translation for that, where we said b dashed is 2. Oh, so we have b is equal to -2 and 2. So what is b dashed? B dashed is 1, 2, 3, 4 minus 2. So it's 4 minus 2. Let's look at c and c dashed. C dashed is 1, 2, 1, 2. So it's 2 and 2. Okay, let us complete the translation for the following. We know that a dash went from x, y, so it was -2 and 3. Then we went to, okay, so how do we get from -2 to 0? So -2 plus 2, so x plus 2, right? How do we get from 3 to -2? We went y minus 5. What about b? We went from -2 to 4. So -2 to 4, we go plus 6. So x, we plus 6. This is why it's so important to understand how to do an equation by just looking at it, seeing without having to write the equation. And then we can see, this is called evaluating algebra by inspection. 2 to -2 is -4. And there we go, y minus 4. What about c? We go from -4 to 2, so that's again x plus 6. And then y goes from 2 to 2, y stays exactly the same, so y stays y. Okay, well done grade 8, that was translations. We're now going to go on the last one, which is enlargement and reductions.